Welcome back to Geometry. We're going to take a look at a problem out of our new Common Core book. And this is a problem-based task. And what the book tries to do, which I applaud them for their efforts, is they try and take a problem or a concept that we're working on in geometry. So as you know, for these past week and a half, we've just been dealing with rules and properties of a parallelogram. Okay, and so this book has now tried to create a real world problem from a parallelogram, which I think is cool. I think more math books need to do that, just on a side note. Okay, so the first thing that we should do is when we read this, it's always smart to underline or highlight keywords that we think that we can use that are important in solving this problem. So as I read this first sentence, it says a bridge truss is in the shape of a parallelogram as pictured below. Now, we may not know what a bridge truss is. In fact, I'm not really sure what it is. But one thing I do know in this sentence is I know that we are told that the shape is a parallelogram. Now, that's huge. Okay, because now we know that all of the rules of a parallelogram exist here. So I know that opposite sides are each congruent. I know that the diagonals of a parallelogram will bisect each other. Okay, so just as a result of that first sentence, I can do all of these marks and more. I won't do all of them. We can show that the opposite angles are each congruent. These two sides are parallel. And there's many other things that I can mark up. For now, I'm just going to keep this. All right, let's keep reading. To support the truss, steel cables are placed on each of the diagonals of the parallelogram. Okay, so to support the truss, steel cables are placed on each of the diagonals. So in a sense, these diagonals are now steel cables. Okay, so think of these diagonals as steel cables. All right, then engineers are concerned with the tension in one pair of cables and want to put a strain gauge in the center of the two cables. All right, well, that's huge too. Let's underline that. Put a strain gauge in the center of the two cables. Now, even if you don't know what a strain gauge is, I have to be honest, I don't know what it is, okay? But what it's saying is that we're going to put this thing, let's call it S for strain gauge, in the center of our two cables. Well, we just got done saying that the two cables were the diagonals, right? So our two cables are going to equal our two diagonals. And then we have this point in the center, and let's call it point S. All right, I'm going to use point S. This is going to stand for our strain gauge, right? So S is going to be our strain gauge. All right, then let's keep reading. And if the tension is too high, these cables could snap. How will the engineers determine where to place the strain gauges without measuring the length of each cable? Okay, so how will the engineers determine where to place the strain gauges without measuring the length of each cable? Well, how I'm reading this, and let's underline that too, because this is what we're really being asked to do, right? How will the engineers determine where to place the strain gauges without measuring the length of each cable, and then prove that the engineer's decision will work? Okay, well, I can tell you with certainty that the engineers want to place S, or place the strain gauges, and we'll just say point S, at the midpoint of each diagonal. And remember that in this problem, each diagonal was our steel cable. So our two steel cables were our two diagonals. So the engineer's goal or their proof of what they're trying to do is place S at the midpoint of each diagonal. Well, few things. One, we know that since this shape is a parallelogram, we know that this point S at the intersection point will be at the midpoint of these two diagonals. So we already know that, but what we're being asked to do is we're going to do a two-column proof. We're trying to prove that point S is at the center, okay? But what we can't use is that we can't use these points. So we have to ignore, we have to just get rid, let's erase all this, I'll go ahead and use black, but we have to pretend that we don't know that diagonals in a parallelogram will bisect each other. So we have to ignore that. We just have to pretend like we don't know that. And so we can prove that, and I'll show you how. But let's go ahead and draw these back in. So here's our two steel cables. All right, so we're going to start on our proof. One, we're going to say that ABCD is a parallelogram. And how did we know that? It was given to us. Two, so if we want to think about how we can get these marks on our shape again, if we prove that these two triangles are each congruent, then by CP/CTC, these segments will be equal. So that's our goal, is we need to prove that this triangle is congruent to this triangle. I didn't mean to put one here, but just that these two triangles are each the same. And if we can prove that they're each congruent, then by CP/CTC, I can put these marks back up. All right, so let's start with, we can say AD is congruent and equal to CB. And how did we know that? Well, that's definition of a parallelogram. Opposite sides are each congruent. So for 2, you could put this, or you could put opposite sides are each congruent, either way. For 3, let's say vertical angle 1 is congruent equal to 2. So angle 1 is congruent equal to angle 2. That's by definition of vertical angles. All right, statement 4. So now I have a side and an angle, a side and an angle. Let's say that AD, segment AD is parallel to segment CB. And that's also going to be definition of a parallelogram. Okay, 5. Since these two lines are parallel and they're cut by one transversal, which is our steel cable, then we know that alternate interior angles are each congruent. So let's put 2 marks here, and we'll put 2 marks here. We'll call this angle 4 and angle 3. So angle 3 is congruent and equal to angle 4. And that's going to be because alternate interior angles are each congruent. Then statement 6, now what we have here is we have angle, angle, side, angle, angle, side. So I can say that triangle A, let's go ASD, is congruent and equal to triangle CSB. And that's because of angle, angle, side. All right, then statement 7, I can say that by CP/CTC, AS, and let's put, I guess, 3 marks here. So I get to say that AS is congruent and equal to CS. That's by CP/CTC. And 8, I get to say that DS is congruent and equal to BS, and that's also by CP/CTC. And so we'll put 4 marks here and 4 marks here. All right, therefore, I am now allowed to say that S is the midpoint S is the midpoint of, and how are we going to say that? S is the midpoint of AC and DB. And how did I know that? Because we just showed that these diagonals bisect each other. Thanks for watching. See you next time.